All right, let's pull back the curtain on something we use every single day, but probably never think about: DNS records. Seriously, these are the hidden gears of the internet, the unsung heroes that make sure everything you do online, every click, every search, every email, actually gets where it's supposed to go. I mean, really think about that for a second. You type a name into your browser, hit enter, and boom, you're there. But what's happening in that split second? How does a simple name connect you to a machine that could be halfway across the world? Well, that's the magic we're going to unpack right now. So at the very heart of this whole thing is the domain name system, or DNS. And the best way, the absolute easiest way to think about it, is as the internet's giant phone book. See, we humans are great with names, but computers, they need numbers, specifically IP addresses. DNS is the incredible system that does that translation for us, connecting the name we know to the number the machine needs, all without us even noticing. Okay, so let's follow the journey we all take 100 times a day: visiting a website. The moment you press enter, your browser kicks off this hunt for the site's digital address. The first place it looks is for an address record, what we call an A record. This is the most direct map there is, linking a domain name straight to its numerical IPv4 address. But you'll also see these AAA records, with 4 A's. They do the exact same thing, but for the newer, much, much longer IPv6 addresses. You can think of it as the internet making more room for all the billions of devices connecting to it. Right, but what happens when the name you're looking for doesn't point to a number at all? What if it's just a nickname for another location? This happens all the time. And that's exactly where the CNAME, or canonical name record, steps in. It's basically a forwarding address. It tells your browser, whoa, hold on. The IP address you want isn't here. Go look up this other name instead. That's where you'll find it. So check this out. Here's a real-world example of how that works. Your browser looks for a blog, but instead of an IP, it finds a CNAME, so it follows it. Then it finds another CNAME and follows that one too, until it finally lands on a name that has the A record with the IP address it needs. Now, the genius of this is flexibility. It means a big service provider can change their server IPs, and everyone pointing to them with a CNAME automatically gets updated. You don't have to do a thing. All right, so we've found our website. Cool. Now let's switch gears and trace the path of something else we do constantly: sending an email. The journey is a little different, but you guessed it, DNS is still running the show. So when you send an email, your mail server needs to know where in the world to deliver it. And it finds this out by looking for the domain's MX record, which stands for Mail Exchange. Just think of it like the specific postal address for a domain's email. It points directly to the mail servers that are set up and waiting to receive messages. And this is where it gets really clever. You can have multiple mail servers, and each one gets a priority number. The sending server always tries the one with the lowest number first, so priority 10 in this case. But if that server is down for some reason, no problem. It just moves on to the next one in the list, priority 20, and then 50. It's this amazing built-in backup system that makes sure your email almost always gets delivered. Okay, so the email has arrived, but the journey's not quite over yet. Now we hit a super important security checkpoint. How does the receiving server know this email is actually from who it says it is, and not from some scammer trying to trick you? This is where the incredibly versatile TXT, or text record, comes into play. It's basically the Swiss Army knife of DNS records. Why? Because you can put just about any kind of text you want in it, which makes it perfect for all sorts of verification and security jobs. And here's a perfect example. See this line of text? This is something called an SPF record, which stands for Sender Policy Framework, and it lives inside a TXT record. This little piece of text right here is one of our most powerful weapons in the war against spam and email scams. Yeah, think of these protocols as building a digital fortress around your email. SPF is like the gatekeeper. It's a public list of all the servers that are actually allowed to send email for your domain. Then DKIM adds a digital signature, like a wax seal in a letter, proving the message hasn't been messed with. Put them together and you protect your brand and make sure your important emails actually land in the inbox, not the junk folder. So we've looked at the individual pieces, right? The A records, the CNAMEs, the whole shebang. Now let's just zoom out for a second and look at the bigger picture. Why getting this stuff right is so critical. And this little cheat sheet here ties it all together beautifully. A&A records are your direct address, CNAME is your flexible nickname, MX handles your mail delivery, and TXT is your security guard and verifier. Each one has a very specific and very important job to do. And let's be crystal clear, getting these records right is not just some nerdy tech task.
A typo in an A record, your website disappears. A bad MX record, your emails vanish into thin air. A missing TXT record, and suddenly scammers can start impersonating your brand. These little lines of text have huge, real-world consequences.
Which really just leaves us with one final question to think about. You've got your digital address all set up, your little corner of the internet. But have you checked the map lately? Are you absolutely sure that every single record is pointing exactly where it should, guiding every visitor, every customer, and every email to the right place?